not going to suck. This is relevant for 15 years, yeah. So people say Call of Duty and forever doing it, almost every release. Yeah. So I'm going to talk about Unity systems. I'm going to talk about existing UI systems in Unity. Show you all the new stuff. And as soon as you can see the new stuff, you'll be like, oh my god, this is amazing. This is so cool. So really, I'm going to be talking about this for like 40 minutes or so, and then I'm going to talk about ET5 and like some super like new stuff, new super unreleased stuff, super hot stuff. Yeah. So yeah, cool. New system. It's out this summer for any of you asked me. So I'm going to talk about current Unity GUI methods, which are all pretty rubbish. I'll be honest. We're going to be talking about how to create visual UI in the UI system, how to make it interactive, and how to edit and stuff like that. So current GUI system is like GUI game objects, which are like you go to GUI text or GUI texture and stuff. And they are horrible. They are horrible because Unity likes to be visual. It likes to have, you can see the ring, you see the teddy bear, like you can see all that visually. It wasn't like hidden behind some like text. However, the old GUI system, which has been out before dinosaurs were around, basically, the object exists in the scene world, but it renders in the screen world. So like, it's there, but it's only being rendered there. You can't, it's not visual, and then it's horrible, so you can then position text, and if you have this image, you try to make a hellfire and squash it, it's just not good at all. It's a horrible way of making a UI. So artists like it because they're like, yes, my artist in the game, they can make their art, bring it in, and they dump it in the corner and say, oh yeah. But programmers will be like, wait, I have to actually code basically everything about this. Really crap. Another one's on GUI. So that's basically programmers like, favorite thing, where they can draw out the UI element, a button, draw it out 10 by 10, 150 wide, 150 tall, put some text in, trigger a function. Basically, programmers are like, oh yes, I can do whatever I want. This is cool. Artists are like, where's my art? So the artist would create some awesome UI, some really next level UI, and then they don't actually see it until the game is running, right? They want to position it and make things scale and stuff like that. So people got fed up because making it for a long time. I remember when I started using Unity, like many years ago, it was promised to me then. So third-party plugins, so people decide to make loads of like different alternatives to GUI systems and basically extend Unity. Most famous one's NGUI. It's basically everyone and their dog uses. And that's the guy who makes $1 million a year on the asset store, so he's living a very tidy life. We actually hired him to make the back end for this UI system, so that's cool. But yes. So yeah, 4.6 and beyond. So this will be out this summer. It's also be free, so you can use it all for free, so that's cool. So yeah, I'm going to get right to it. So rather than using slides, because I don't have presentation slides, I'm just going to do it more hands-on. Where is it? Where's the GUI? Okay. So the GUI system, so the GUI system is all visual in the scene view. Everything is positioned in the scene view, and you position it accordingly. Rather than it existing here, but you can only edit it there or see it there, rather than all existing code, it's all visual. So that way artists can bring their UI in, dump it into the game, put it in the position to see it, and it looks awesome. So what we're going to do is we're going to create a canvas to begin with. So I'm going to game object, create UI, and here I'm going to go canvas. So currently there's nothing, and you'll notice that the canvas is a big empty space, which is positioned there. So what the canvas does is it basically acts as the space you draw your UI into. It's like a container for your UI. It's like, for example, this scrunched up, so this name badge is a canvas for all the different elements on here, so I can carry it around. So the canvas is kind of like the holder of the UI elements. So what you'll notice is that the canvas itself has a component of screen space. And what that does is what size your game is, so whether it's on an iPhone or it's on a big 4K monitor, it will adjust the canvas to your screen space, so you can test it with different types of resolutions. So for example here, the canvas is pointing to game view, so as I change the game view, for example, the canvas is going to change accordingly, and all the UI will shift around the structure accordingly. If I said, for example, set a game view with 350 by 400 pixels, canvas will then, okay, this is a beta, so if stuff goes funky, yeah, like that. So what you'll notice here is that the canvas is now 350 by 400. It's basically locked into that single file. Sorry. Why is my... So let's go three aspects. So we have our canvas. So the canvas is basically a method that you draw like all the items onto. So you have your canvas, and it sits there like that. So what we're going to do is we're going to just create a simple image. So the way that the UI system works is basically you have your canvas, and then all your elements you want to draw onto the canvas. So for example, the text, the badge, the images, the green and stuff, then draws onto that canvas. So we have here an image, so just a very standard basic image that's being positioned. So you can imagine this to be like a watermark or something like that. And I can position it around. So as I position it around with the canvas or in the editor, basically you can see it all moving around in the editor. So if I position it there, for example, that is now technically a health bar in the corner. It uses the same sort of gizmos as the 2D tools. So I can then position this as like a little health bar in the corner or something like that, or a warning message, and that will now sit in the corner. Now, the downside of this is different sizes of screens. So for example, if I go back to an iPhone, that's obviously going to be a very different screen size as to like a projector or a very wide screen. And the problem here comes from this. So say like I have my UI element, it's in the corner like that. Now let's say that I test it on a 350 by 400 screen. What? There we go. Cool. And as I change my game view, it's basically going to sit there. It's not going to sit properly. So it's fine for that resolution, but on the end user's device, the people who are actually going to buy your game, it looks like crap. So what you can do is you can set an anchor point to say where it's defined on the canvas. And this is this little thing here. Now, it used to be yellow, and everyone on like the alpha testing called it a flower, or the flower. Our developers hated it and changed it white, and then we pointed out, you know, flowers can still be white. So yeah. So I'm going to call it the flower. So the flower is basically a customizable anchor point for this UI element. So as I click my UI element, basically I've got the flower, I can then take this flower and drag it, basically position it to a section of the screen. So I could say anchor to that bottom right hand corner. That will always, no matter if it's on a screen this big or a screen this big, it will always anchor to that bottom right hand corner. So now what you notice is that as I resize the UI element, oh look, it's always sitting in the bottom right corner. If I change it to 350 by 400, it's going to sit in that bottom right corner. If I change it to 1024, if I change it to 1610, if I change it to basically any aspect, it's basically always going to sit in the corner. Go for it. Is there real different anchor? Every single UI element has an anchor. So for example, I could have this here, and then I could have some text inside this, this UI element, basically anchored in the top left-hand corner of the text. So just before anyone points out, I'm going to point out what happens if you have UI elements on a scale. Well, actually I'll do that in a bit. So I've got my UI element like so. So let's position here. So I don't like just standard base white blocks, so let's actually import some UI. So I have here a metal panel, just a simple UI element. So, okay, so slight off track. If you want some really awesome UI, go to this guy's website, kenny.nl. He makes really, really good assets, like 2D. He basically makes like a pack of like assets of aliens and stuff, and then he makes like swords and things, and it's all 2D. It all work on Unity. It's all sprite based. He also make he also has tappy plane. So you can make a tappy chicken, tappy flappy, whatever. He also makes a UI packs. This is pretty cool. So basically, he gives away this all for free as well, which is crazy because I'd actually paid for it. I'm not complaining. So I'm using he's released a space one recently, but it's not up there. So yeah. So I've got here a metal grid. So I want it to be a little panel somewhere in my game, somewhere in my canvas. So what I can do is I can go to my image and then import my grid. So the way that the UI system works is after the 2D developers finished sort of working on the first piece of 2D tools, they went over to make sure that the 2D tools would work with the UI system. So basically, you know, you're making two 2D systems, it'll work together. So if I go to here and I have a texture type, I can set it to sprite, which is the same that you do for 2D. You can set it to multiple as well, and I'm going to click apply. So now I have a sprite, which is this metal canvas. If I select my image, basically I can then apply metal panel. So I now have metal panel. That looks quite squashed. Great, so I have a metal panel which will basically lock to the bottom right of my screen. So one thing you'll find is that the metal panel will probably look quite horrible. And if I scale it. So what you'll notice here is that as I scale it, basically it's going to become squashed. So if I have this as like a health bar, what you'll notice is that like it's basically going to get pulled down and it looks really horrible and bad. Well, what you can do is you can set up the image type. So we've got metal panel. The 2D guys, they carried over their vertex rendering system over, the vertex coloring of sprites. So for example, I could bring one panel in, have a second panel in my UI, have one as red, have one as green, Or what do you say, purple? Pink. Pink. Okay, right, fine. Pink.
Still purple.
And the stats, basically, it's still one draw column of stats because it's still referencing the sprite. It's still referencing one draw. Okay, let's go back. Okay. So what you notice here is that we have the image type, we have metal panel, we've got the color, we can set up a 3D material, I'll talk about that later. We can also preserve the aspect. So let's preserve the aspect. So what preserve aspect does is as we rescale the UI, basically rather than it stretching out, so for example it could be on a tiny little iPhone screen or a bigger screen, basically it'll preserve the aspect as you change it between different ratios. I'll talk about that later on. As well as doing that, what else can you do? You can also go and make it tiled. So I can now make my UI tileable, which is quite cool, I guess. As you drag out the areas, that's nice. Another thing you can do, you can make it filled. So basically you can set it to be simple, which just places it. You make it tiled if you want a background. You can make your image filled. So image filled is really useful if you want to make like a health bar or something. Because what image fill does is it auto masks your sprite. So if you have a sprite and you have a health bar, it will basically show and reveal it as opposed to squashing it, which is what GUI actually does. So let's say we want our sprite to be filled. I'm breaking the rules of Unity and moving the inspector to off the right hand side of the screen. So I've got my UI element there, I've got filled. I can then set my fill to be in a certain direction, so I can set it to fill horizontally or vertically. If I set it to fill horizontally, like this, I can set the fill origin to be left and I can reveal it. So I can basically say, oh, reveal it over time, or for example, like, you can have a health bar, so every time you get hit, the health bar goes down. And rather than it taking like, an image and then like squashing it, it's actually like peeling it back and hiding it, which is a better way of doing a health bar. You can also set it the fill origin to be like on the right hand side, which is cool. You can set it to be vertical, so you can set it to be like a fill rate like that. Another cool thing, so this is my favourite one, so rather than just doing horizontal or vertical, you can do radial fills as well. So you can do a radial fill at 90 degrees from the bottom left hand corner. So you can have like, for example, like a driving like game, and then it increases like, what's it called? Your speed that you're going at. Rate, I don't know. I can't drive, so yeah. You can also fill it radial 180 degrees, so that would be more useful for like a curved sort of radial UI system. And you can also set it to be radial 360, which is like, so you have like a clock or something. So basically, what it's doing is it's taking the sprite, auto masking it and cutting it out. People didn't like GUI texture where basically you squashed it and it looked all horrible. They like it and it peels back. So if I go to a UI system, so not Unity, the Wi-Fi code kicked me out. Whatever. Okay, so you can set that up. Okay, so before someone asks me, what if it looks horrible? So basically you've got this big UI system, you've got this big UI element that's like this. And people sometimes say to me, okay, that's nice and all that we have this, logo in the corner of our screen. People say to me, okay, it's nice that you have this you have this little UI logo in the corner of your screen. That's great, have it in the corner there. That's great on an iPhone, but what if you're on a massive screen? It's still going to be that size. If you wanted to change scale based on the percentage of the screen size, well, this is more black voodoo magic. So you see here you have the flower, and the flower is your anchor point. You want to anchor from the center, from the side. This flower actually detaches. There we go. So you can actually detach the flower and define how wide it is on a certain screen. So I can set my flower to then drag it to here. So it'll anchor from that point, 28% of the screen to 12% of the screen. Which now as I go from screen, it's going to anchor that. And what you'll notice is that they gave you in the bottom corner, so they're going to scale based on the percentage of the screen. So let's use this in an actual example. So let's say we have, let's say we have a UI element in the middle, and we want the UI element to be 80% of the screen width. what you can do is you can set your anchor, you can get your anchor. I'm using a touchpad, so sorry. So what I can do is I can set my anchor, I can actually pull out my anchor elements. Basically define the percentage of the screen width. So I can say, like, I want this UI element to be 100% the screen, or I can sort of shrink it down and say, I want it to be 10% from that side, I want it to be percentage from that side. So now that's going to be 80% of the screen width, no matter if you go to an iPhone or like a big wide screen. And then we can then open up our sort of like UI, pull it out. So now as I change that game view in the bottom right corner, it kind of jumps because it's a meter and all that. But you can see like there, for example, you've got a wide UI and then like another iPhone and basically scale that UI down. So basically the anchoring system allows you to kind of like define a percentage of how big the UI is on your screen. So some of you are probably going to point out, like, this looks like garbage. Like, what is this all about? Especially, I mean, if it's a small screen, so let's say like this, that actually looks alright. That doesn't look too bad. However, if you're then building like a 4K monitor to go against like, you know, massive die-hard PC fans, it's going to look at that. That's just 2D artists here are having a small amount of parts tax on my brain. So what you can actually do in Unity in the sprite editor in 4.6 is set up 9 slicing. So put your hand if you know what 9 slicing is. Okay, a couple of people. So 9 slicing is a... It's not about the internet. Oh, there's some runes. Brilliant. Sorry. I should have read this. 6. Get the one allowed to go on the internet. Great, cool. Okay. So 9 slicing. So 9 slicing is basically a method of taking the UI and basically making it attractive on all screens. So what it does is it basically says that does not scale. That does not scale. Well, you can read, obviously. That doesn't scale. These scale, but the center bit scales as well. Because what you can do is you can resize your UI to any size. It will basically maintain, you know, the size of the UI, so it won't stretch out. It won't look horrible. A prime example of this is Pokemon on the Game Boy. Okay, yeah, so what are your examples? Charming to use them both, right? So they use 9 slicing, unlike the Pokeball. So basically that doesn't scale, that doesn't scale. So that way they can use this UI on every single menu. I'll kind of bring Pokemon for you now. On every single menu, basically scale it, and it will always maintain this aspect in the corner. Well, Unity has basically, you can do 9 slicing in the sprite editor. So you know the sprites, when you chop up sprites, you can do all that, and it's like 3D magic. So let's go to my metal panel. So we have our metal panel. Let's go to the sprite editor with the metal panel. So I've got this here. So I've got the sprite editor open. So this is where like, we chopped Iron Man and stuff like that. And what you'll notice is that on each sprite will now have a name, but also now have a border. So the border is the 9 slice. So what you can see here is you also have a little green arrow. So you can then pull down where the 9 slice starts. So we can say, okay, so we want that to scale. So we've got that center bit. We can pull this here across. So it's like that. So that bit will stay in that ratio, same in that aspect. That doesn't scale. This will basically stretch up and down, but that's fine because it all looks the same. So basically we can then go through and 9 slice this whole item. This 9 slicing also works on like a sprite sheet of lots of different UI elements. Each one you can 9 slice individually. And once we've set that all up, we could also specify that 10 by 10 by 10 and click apply. We can then select our UI element, change it to sliced. Look at that. So no matter if it's that size or that size, basically all the corners are going to stay. So now what I can do is now I can make my game, that's 80%. So now I'm making my game, so that's 80% of the screen. It's maintaining the aspect of the corners and the sides. However, if I built it for like a smaller, crappy, like 350 by 400 screen, it's still maintained the same size. So now you can make UI for all sizes using line slicing, and it's super sexy. So you can also use UI and use line slicing in a very different way. So if I bring in this one here, so what you'll notice, we have this green tab in the corner. Now obviously, if I pull this down to here, that's going to scale that entire top bit, basically, and it's going to pull out that middle section there. But because the UI isn't restricted, because the line slicing isn't restricted to like, it must be 13 from the top, 13 from the side, because it's all customizable, I could then set that to be, for example, there, set that to be there, and then set this to be like, so can anyone take a guess what's going to happen? Okay, other than that. Okay, can anyone take a guess what's going to happen there? Oh, it's going to scale, it's not going to scale that bit, it's not going to scale that bit, it's going to scale that bit in the center there. So now we're always going to have the same size on all screens, that little like top in the top corner. So something like that. Let's go to the UI. So we've got here on the tiny little screen, tiny little like bit there, if you want like a little off button or an exit button. Whereas if I then set this to be like a free aspect, it's the same size. So the line slicing isn't restricted to, for example, being only like 10 pixel, 10 pixel, 10 pixel. You can actually customize it and basically pull it out to whatever size you need it to be. So for example, if I took this to this UI, that will always remain the same size in the top left-hand corner. Here. If you, I don't have an example of this. If you set it to tiles, say like you had some UI which basically had line slicing around the outside edge. So line sliced tile. That is not useful in any way whatsoever. It's still not useful in any way whatsoever. Shit. Why is Windows 8? Yeah, real tiles. Okay, not useful. Okay, so say like I had, okay, so, where's my spread? Okay, so say like I had, for example, the arrows around the outside edge. Say like this bit had like a tile, like a checked tile. You could have it 9 sliced, but also tile the center of that 9 slice grid as well. It's difficult to explain as I have a demo. It's really running out of time. Cool. So we have an image. So let's say we have the image like that. That's awesome. So what we want to do is we want to have text as a sub-object of that image. So let's make this down here. I'm going to make this a button in a second. And let's connect to the top left-hand corner of the screen. So yeah, like that. So let's say we want some text in the middle there. So what we can do is we can say, go to the image, we go to game objects, create UI text. So we've got text, position it because it's all visual, position it up in like the center. It's quite difficult to see, so I'm just going to say some of the colourful text. Okay, set it to the center. We can also set up all sorts of things. We can set the font size. We can also set the font size to scale with the UI as well, because every UI element has an anchor point. So I can say to this, text, scale with the width of this UI element. So always be this scale with the UI element. So now when I take a UI element, it doesn't do it. Okay. Okay, it does do it now. No, it doesn't. Please do it. No. Okay, it's in beta. So we have the text here, and then we can type in, we can do all sorts of font styles, we can do rich text. So we know I can actually do text, rich text typing mid-sentence. So if someone give me a sentence to write out anything.
Brown fox jump over the
Big brown fox.
big box.
Big brown fox.
What are you so
Big brown fox jump. Okay, let's just call it the big brown fox. Okay, so we've got the big flying fox there. What I can do is I can then bold out certain bits by writing HTML or similar sort of HTML. So, okay, that looks shit. Okay, let's do something different. So let's say, brown. Okay, so let's do color equals red. You can also pass it a RGB, hexadecimal, right? Oh, wow. We can also change the size. So the big, what size should the big text be?
0 point.
0 point something.
Oh.
So I can have it say big, and then brown is brown and so on and so forth. So basically you can do that, which is pretty cool. So yes. So basically you can then position it and play around with text. So, you can also set up effect style. So currently down here we have the shadow. So we can set that shadow to be like, what color should you set the shadow to be? Bear in mind we've already used the text way more than we should have. So yellow shadow. That looks like something you make in Microsoft Paint. But just for example, you can do something like that. You guys picked the colors, yeah, and sentence. So I'll make it. Yeah, so you can do that. You can do alignment. You can do all like the usual stuff. You can actually do it in like the UI system. Yeah, you can play around with it a lot more. So set up we have this text. It's probably quite possibly the worst button ever. We have this image in the corner, and that's great. So we can make our game. The player will be like, why the hell is that in the corner? What purpose does it serve to my game? None at all. So what we can do is any UI element, which is like an image or a text or a sprite or whatever it is, can be made interactive, can be made into a button, can be made to do something. So if I, for example, let's create a where's the cube? Okay, so I've got a cube there. So what I want it to do is I want the cube to do something when I push a button. Let me show you the direction. Okay. So I'm using it. Okay. So I've got my UI. So let's turn this into a button. So we click the button, the cube will do something. So this is some more black magic. So basically we have our image. We have our image. So guess how we add a button? We're going to add a component. Go down to the UI section. And then we can turn this image into a button, we can turn it into a scroll bar, we can turn it into a slider, we can turn it into a toggle, we can turn it into basically an input field. I'm going to stick the button at the moment. So that is now technically a button. Cool. So with that button, I can turn the text into a button if I wanted to. With that button, you have a couple of options here. So the first option is type of tint. Okay. So basically, every button has some form of input when you like hover over it, you click on it, it does something. So currently, we have a color tint. It's a base color tint that basically, as our cursor hovers over it, we click on it, it does this simple color pick. Super easy, super simple. So I could set it up, because you guys are obsessed with the color pink, I could set it up so that when I click on it, it goes pink. And I could also define how long the fade duration is. So let's say 4 seconds. So as I hover over it, it's going to fade to, and then as I click on it, it's going to fade to pink over 4 seconds. As I let go, it's going to fade back over 4 seconds. And yeah, so that's just a simple color tint. So if you want a UI element, you want to basically just switch colors and sort of fade around.
Can we set a custom texture while looking to that?
Pardon?
Can we set a custom texture when you click the buttons?
Yes, I was about to show you that. Okay. So that's just the same base color tint. You could have no transitions. You could basically have, like, your user has to guess that that's a button, for example. You can have a base color tint. You can do a sprite swap, so you can swap it out for a completely different sprite. So if you had a sprite which is like an up button, a sprite which is down button, a sprite which is push, you can then swap it out. So I could then say here, this is what this image is. Let's swap it out for a tick when I hover over it, and let's swap it out for a smiley face when I click on it. So now, Yeah. Yeah, so you can do that. Yes, you can do sprite swap. That's okay, it's a bit boring. The next one is truly the icing on the cake. So the next one is animation. So what do you reckon I'm going to be able to do with this whole UI system? I've shown you it already today. Pardon? So you know that whole mechanism state machine from Teddy Bear? So you've got a Teddy Bear running around and he has running and jumping and stuff like that called the state machine. You can use that on the UI system, which is mental. So basically, I click auto generate. It's then going to ask me to call it controller. So let's call this brown box button. So now, if I select my image, look what's on it, an animator controller. Okay, so let's have a look at the animator for this button. It now has an entire state machine for normal, highlighted, and pressed. It has clips basically saying, at this stage it's highlighted, at this stage it's clicked and stuff. So if I show you this, for example, not full screen, whoa. So basically, you have three states. Basically, you also disabled, but they might have to do that, I'm not sure. So, hang on, so you highlighted normal and pressed. So basically, you have color tint, which is basic normal. You now have normal, highlighted, and pressed. So you click buttons that do that. Not every button's going to do that. Maybe I want to highlight on it and it spins. Maybe I want to click it and it changes volume. So you know the whole animation system I showed you with the rocket? I can turn that rocket into a button because I'm using all the animation data. So if I go, where's my number? Okay, look what I have here. I have normal, highlighted, and pressed. So when I highlight it, it's got the base data for it to like scale. So someone picks something from it to do when I highlight it.
Rotate.
Rotate, cool. I love it. Yeah, my UI is just okay, so what do you want me to rotate it by? 45, 45, 45. So now, because I'm using mechanism, because I'm using some animation system, I can animate anything about my UI. And it's doing it as well, which is quite mad. Yeah, and when I click it, what's it going to do? It's going to go green. So I know this is a really crude example. So we have here. So for example, the teddy bear, which is idle, has running, has walking, for example. I could have the teddy bear as a button. He's idle. When I hover over it, he's walking on the spot. When I click on him, he does a jump, for example. So you can just use you can use mocap data on a UI system, which is just like, well, this takes it like to the next level. You could have it so like when you highlight it, it does a thing. When you click on it, it basically dims the volume and then increases it over time and stuff. You had a question?
Yeah, can you anchor UI elements to other game objects?
Pardon?
Can you anchor UI elements to other game objects? So say you want a floating health bar or something.
Floating health. Yeah, so you want like the character to have a health bar outside.
Yeah.
I'm about to do that.
Oh.
You're ruining all the fun. Yes, you can do that. So I'm going to show you how to do that in a sec. It's not going to be on a character. It's going to be like in the world space, but like it's the same thing. Cool. So we have a button. It does an incredibly crude type of animation, but you can see that I basically can't make anything about it and do all that sort of stuff. So now that we have a button, let's actually make it do something. So what you have here is underneath the button's properties. Let's go out here. Where's that? So we have here on click. So basically, this is all just the transition stuff to define that it's a button. But there's very little point of a button if it doesn't actually do something. So here's where the magic happens. Basically, if we click this plus, we could then say an object, what we want to do with the object, and what message we want to send to the object. So let's pick the cube. I'm going to click on it. Let's go to the cube. what do you want to do with the cube? You have access to all its components, you have access to its game object, you have access to transform, you have access to its mesh filter, its mesh renderer, its box slider. If it has a script, you can access a function on its script. I'm going to do that a bit later on with a rabbit. So let's say go to the cube and let's do something really simple like change the name of the cube. So on click, I'm going to change the name of the cube to what?
Doggy.
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 Doggy. Okay, so as well as doing that, so it's going to change the name of the cube to Doggy, we can then set it to do something else as well. So let's go to the camera. What are we going to do with the camera? Zoom in. Okay, let's change the
Field of view.
okay, which one?
Field of view.
Field of view. And let's give it a value. So what are we going to change it to? So it's kind of 60, 30. So yeah, it's going to look crazy. So I clicked on it. Cube is now Doggy. Main camera is now field of view of 30. So yeah, basically it allows you to click and then access and run those things. Right, someone's going to point out something really horrible in a second. And that's like, what if you wanted to detect when the mouse hovers over it and hovers off it and so on and so forth. So I'm going to go to a completely different scene and show you that. I'm so going to run over today. Scenes, okay, so we have a simple scene. So this is UI. I ignore the thing with the floating background. In the world space, as I move my mouse around, basically, oh shit, I should change this close. So as I move my mouse around, basically it's going to tilt the window. So it's actually like detecting where the mouse is and tilting the window. And what you'll notice here is I have a button. When I hover over this button and click on it, it's going to activate a different area. And you have things like sliding scroll bars and stuff. I'll show you how to do that in a sec. So let's say that this. Oh, there's a button. Okay, so let's take the text and shrink it down. So I've got this logo here, which might look kind of familiar, and I'll scale up transparency. So I want to turn this into a button, but rather than just having click and it does something, I want it to basically, when I hover over it does something, when I hover off it does something, when I click on it, when I scroll on it, when I push a key whilst on it and stuff. So what the UI devs have done is they've made a base sort of they've made some base game objects for like typical things, like a button, or like a slider, or a scroll bar. These are all like base components that you can use. What they've also done is they've created a whole API for you to basically create whatever UI element you want to do. And I think the plan is to also open source the UI system, so you can go into the text bit and completely change how the text rendering works, wrap it around a 3D object as opposed to a flat object. Basically do whatever you want with it. I'll talk about that a bit later on. So here is like base stuff. So the button is obviously click, it does an event. So what if we wanted to extend that? Well, we have this magical new component, which goes to event trigger, and then here it looks super boring. It looks like the most boring component in the world. However, if we go to the event trigger that's on the watermark, we can do point to enter, point to exit, point to down, point to up, point to click, drag, drop, scroll, key down, key up, select, deselect, and move. So if it moves, we do something. If we hover over our pointer, which is a mouse or a finger or like an Xbox controller, it will do something. So if I build this, my finger and the mouse are basically the same like a pointer. So let's say on point to enter, what's it going to do? It's going to go to the bunny. So I've got bunny in the background. Where's the bunny? Let's position the bunny there. So let's say on point to enter, go to the bunny. And what we're going to do with the bunny? Let's go to mesh renderer and let's change its color. So let's set a new material on it. So it's going to ask for a material for me to give it. I've got a nice red material, so the bunny's going to change red on point to enter. Let's add a new one, so that's on point to exit. What we're going to do, we're going to change the bunny back to white, so let's set a new material. On pointer down, so when we click down on it, it's going to change the bunny to another material, so we can change the bunny to green. So So now what will happen is basically we have this bunny, we're sending across some messages. Point to enter, point to exit, point to enter, point to exit, point to enter. Okay. I can make this text basically do the same thing as well. So basically the event system, the event trigger basically allows you to detect sort of any point of enter. I can have it when my cursor's over it and I scroll, it does something. Or when it moves, it does something, things like that. So I've got one more thing to show you. There is like an hour, no, it's like a 30-minute video on like our blog, basically showing like this UI system and stuff like that. So it goes into a lot more depth. I really don't have time to sort of, I could talk about the UI system for like 4 days, but every week. So yeah. So let's do a simple slider. So the bunny, I feel really sorry for the bunny, because the bunny is probably a bit sick because he keeps spinning all the time. And he's also behind the UI. So let's create a slider to basically change the speed of the bunny between two values. So what you can do is in game object, create UI slider. Where's the slider? Okay, slider's there. So I'm going to position the slider underneath, scroll bar, underneath the logo. And the slider's built out a couple of things. It's got a reveal, sort of like that fill rate, basically the fill that goes from left to right and masks over it, and it has the handle as well. And you can notice it's got a couple of other properties. So underneath here we can set a minimum value for the slider and a maximum value. So the bunny is currently spinning at a value of 1. So someone pick a minimum value and someone pick a maximum value for the bunny's spin. -1, adventurous, and
100.
50 is too much. Deal with it. Okay, so we have this slider between -1 and 50. Obviously I could turn it up to 11. No, here's the spinal tap panel. Okay. So what you can notice is that as I change this slider value, basically it's going to change that slider. So yeah, I've now got a value between -1 and 50. Now that I have that, let's do something with it. Actually, I'm going to change it. I'm going to change it between 0 and 5 to begin with, and then I'll tweak it a bit later on. So now that we have the slider outputting a value, what we can do is we can send this to, for example, a light and change the intensity of the light. We can send this to volume and change the volume, or you can send it to a function. So let's add a change. Let's go to the light in the game. What we're going to do with the light, let's go to the light. Let's change the intensity of the light. So what it's going to do is it's now going to, the intensity of the light is now going to scale between 0 and 5. Yeah. The bunny is probably still super spinning quite a lot. So what you can also do is while you're changing the intensity of the light, let's go to the bunny. Let's open up the bunny. We have different things like game object, transform, we have lots of components. We have spin. So spin's actually a script on the bunny telling it to spin. So let's go in there. There's a function called change spin. Let's go to there. And basically what it's going to do is it's going to go to, and as the value of the slider changes, it's going to change the string of the bunny. Spin script looks like this. So what you do is you extend using the Unity engine to the UI. We have a public function called void change spin. We pass in the slider values float, and then we just change the rotation per seconds. Nice and simple, nice and easy. So now what's going to happen is as I change the slider, well, now the bunny's quite difficult to see, so just as an added bonus, if you go to the canvas which all these UI elements are drawn onto, the canvas also has an alpha slider. So you can go to the alpha slider, more the elements of the canvas. Yeah. Well, okay, see the bunny. So what was it, -1 you wanted? Let's say okay, let's compromise. -5 and 5. So now the slider will basically act as kind of like a middle point. Yeah. So basically you can output a value from the slider. A toggle will be able to change between like the spectrum or the graphic camera or true and false stuff. I have like no time at all, so I'm going to show you a couple of other sort of like pre-made demos. So here is so who's the gentleman asking about if you want to position it above a character? Okay, cool. So we have here a menu. We've then got this canvas there that's rendering this menu. So let's say this canvas wants to be on like an object. Let's put it on the bunny. Okay, so we've got the bunny. So what you can do is you can create a canvas. Okay, so we've made a big canvas. Or let's just use the existing one. That's great. Okay, let's create a new canvas. So let's create a slider. So we've got a slider like that. That's on its own canvas element. Oh no, it's not. It's in beta. So we have here a second canvas. What we can do is rather than render it in screen space, we can render it in world space. So this is now a game object in your game world somewhere. It's absolutely massive, but that's okay. So we now have this canvas here. I can scale the canvas down. Okay. Where's the bunny? We can attach the canvas to the bunny. So then as the bunny rotates and does stuff, bunny now has a health bar sort of. Shit. Okay, it's spinning in the corner, but yeah. It's a bug. Okay, it is there because you can see the bunny spinning. It's in beta, it's in beta. Yeah. Okay, you have a question?
Well, text over a character, you can do that right now with text flash. You can write it the same way, but without the characters, just proximate.
Yeah. Yes.
And you can do all
Yes. Okay, question.
When you make a UI element, always look at the camera.
Yeah, so well, like a world space like UI.
Yes.
Okay, yes you can. So what you can do is you could have a, okay, you've got a canvas. Let's get the bunny's canvas. So here what you have is you can have overlay, which basically exists in the 2D screen space, or you can have screen space of camera, which basically will ask you for a render camera, and then that will render in the screen space, but always like looks towards the camera. So like Age of Empires, you'll help pass above people's heads. They'll be in the world space, but like looking at the camera, like locked in 2D. The world space is more for like, you walk up to like a jukebox, and then you've got like a UI panel on a jukebox, for example. So yeah, yeah, you can. What else? So we have a million other things to UI system, but I really need to sort of move on. Yeah, so come up and find me later on, and we'll talk about it. Sorry about the really crude demo of it. Still making some content for it. So yeah. Another thing you can do is it has a whole scripting API. So for example here, one of the devs made a simple smiley, angry, and Unity logo all in the world space. And then what they've done is they basically wrote scripts. So say like I don't want this to act as a button, I want it to be like a drag and drop game. Basically they've written an API which allows you to detect when I've clicked on it, when I've dragged it to an area, and when I've dropped it, for example. So I can drop that in there, I can drop that in there, for example. And if I get my canvas, so we have eye pointers, so you can say on pointer down, get the pointer data of where it is, so you can actually, rather than just using the base buttons and sliders, you can actually script, if you want to, more complex systems like drag and drop systems and resizing and stuff like that. Yeah, so there's going to be more information on our blogs a bit later on. They're creating more sort of like videos, so basically the first video is showing the basics like canvas and buttons and stuff like that. And the next video is going to be more in depth, next video is going to be scripting, components and stuff like that. So there's going to be more content coming out as they sort of finish it. And there's a couple of bugs and it's going to tidy up some of it, but it should be looking pretty by the end of it. Cool, so I've got 34 minutes. Okay. Click save. All right. Okay. So here is the meat and vegetables. Unity 5. Okay, cool. So I'm into Unity 5. This isn't, I'm not going to get through all of this in 34 minutes. I've kind of covered 2D physics effectively and showed the Flappy Bird stupid thing. I'm going to cover physical-based shading, reflection probes, draw with debugger, I'll talk a bit about lighting, I'll then show WebGL as like the end today, stupid photo. So basically, in the Unity 4 cycle, these are all the things that we sort of implemented. So the animation thing with the teddy bears, like all the state machine stuff. Mobile rigs on shadows, animation window, 2D tools, variants of Linux, Flash, Windows 8, Windows consoles, eventually new GUI system. So Unity 4 is kind of like going from like an empty, like underground Unity 3, like two-man studios. It's actually implementing like 2D tools and actually kind of extending the engine further. But every couple of years, what we like to do, like 2.5, like maybe 3 years, is we like to kind of like break bits of the old engine, kind of update older things of the engine that are quite difficult to change. So for example, if you buy a house, you build a conservatory on top of the house, and then conservatory onto that, and conservatory onto that, conservatory onto that. If you get rid of the first conservatory, it's going to break a lot of like stuff. So what we like to do is we like to, every couple of years, kind of like release a new version of Unity, which allows us to go in, optimize a load of older code that haven't changed in a while, kind of like make it better and kind of overhaul lighting systems. If we overhauled a lighting system, whilst people are in the middle of their games, we would have like, carnage, like right on the streets basically. So with Unity 5, we're kind of overhauling older stuff we haven't overhauled in a long time to kind of like give it more life. And I'm going to show you some stuff that is in it. So yes, Unity 5. There will be a free version and a pro version, like always, and the pro version features are going to be like specific stuff, but most of what I'm going to show you is going to be in the free version, so yeah. Cool. So Unity, the GUI system will work in both 4 and 5 at the same time.
The GUI system that you showed us, is it free or pro?
Free.
Always.
Yes. Pardon?
Release date
When is it?
on Unity 4.6.
Summer.
This summer.
Yes. Yeah. The developers don't like to set dates, because if they set dates, then like we have a Ubisoft on our hands where it's not like I hate Ubisoft. No, like where they set a date and then they cram and basically rush like Watch Dogs for release, and then it gets released and it's so rushed and there's so many points where you're like, wow, they really kind of just copy pasted stuff in there. So what our developers like to do is they're very fussy. They like to release something when it's ready to be released. Miyamoto said like a famous line, like a rushed game can always be bad, but a delayed game can always be good. If you think about it. So you can delay it and it comes out better. Dark Souls 2 was delayed and it ended up awesome. But then Miyamoto's went crazy, so yeah. Italian Plumber is like the mascot of the gaming community. Italian Plumber made by okay, so the first one's going to be rendering, physical-based shading. So I see a lot of Unity games, and a lot of people say, why do my games look blue? Why is the default tint of blue? All my games look blue. Also, the skybox gets positioned in the game, and it looks nothing like the lighting in the game. Basically, the out-of-the-box tools of Unity are you bring your 3D model in, and you have to kind of poke it and jab it and do lots of stuff to it to make it look sexy, basically. So what we've done is we've kind of looked at the art workflow. We've sat down with artists to bring in 3D models, bring in content to Unity. What they want to do is they want to spend weeks on their sexy projects in Maya, bring it in, and it looks as close as possible it can to Maya. Because if you do, they spend ages working on the thing, bring it in, and it doesn't look too accurate. So you're working on physical-based shading. So basically, you'll be able to bring an object into Unity, set up the shaders to basically allow you to customize and build it, kind of tweak values in Unity so you can still bring in your amazing art and then tweak it on the other end. So physical-based shading. So physical-based shading is amazing because basically the shader that we've created, the universal shader, is used on everything in this scene. So for example, the thatched roof. So the thatched roof, which is kind of like soft and stuff. The shields, so I've got a shield example there later on, like shiny the shields. The wood on the floor, like the chips, the mud to make it look wet and muddy. That's all using exactly the same shader. Yeah, people. The only thing not using the shader is the skybox. So yeah, everything there. So that's like a Viking village, which will be like a demo that's released like when it's done, when it's summer, when it's ready. So yeah, Viking village. So this is the universal shader. It was originally called the Uber shader, which I prefer so much because it sounds cool. They were suggesting we call it the standard shader, which is the most boring middle of the road thing you can think of. So we settled the universal. So basically this doll demo, which I'm going to show you in a second, everything on her face and on her uses the same shader. It's just shaded to make this look like cloth. They're shaded to make this look like metal. They're shaded to make her like ceramic and have these metal tints and stuff like that. And it also uses, the shader also uses its surroundings. So it uses the light of the skybox and uses surroundings to reflect all the things that you see. So let's look at the doll. My girlfriend jokes that I see this doll more than I see her, so yeah. It's quite depressing when you think about it. Yeah. So we basically have, okay, we've got a cat, we've got a doll. Okay, doll. Scary doll, yeah. So we've got the scary doll. So the doll, for example, the ceramic face with reflectiveness of the face, and like the leather and like the on her like silk gown. Basically, we're using the same shader to like build it up. But rather than playing around with the doll, because my girlfriend moans that I'm going to play around with other dolls, basically I'm going to play around with the cat. I'm trying to get our marketing team to make these actual balloons that we can give out. Oh my god, it's going to be so cool. So we've got our cat. So our cat looks like a balloon. He's got a reflective surface in there, and I'm basically going to set him up. So I'm going to take this balloon cat, turn him into leather, turn him into rock, turn him into lots of different things using one shader. So, if I just get this down. So, an artist will be, I don't know if you're a 3D artist. Okay, keep your hand up if you have any idea what decal is. I work at Unity, I have no idea what it does. What does it do exactly?
You use a separate UV channel to add a different texture for more detail or something like that.
Something like that.
Yeah.
Yeah. Some people in Unity have no idea what it is. My CTO is like, what is this? It's crazy. Like, most people don't use it. But what we find is people have a 3D model, they bring it into Unity, and they're like, okay, so I've set up like specular maps, normal maps, emission maps, masks, things like that. Which one do I pick? What the hell? What? Reflective, bumped, diffuse, reflective, bumped, vertex lit. Like, is that what I need? No? It looks like garbage. What the hell? Wait, what are all these crazy values? This is nonsense. So basically, how are these specific things? So like diffuse, and then you're like, oh, it's got a normal map, so like, let's make a bump diffuse. What the hell is a specular map? So like, I guess you go specular. But there's no normal map, so then you go bump specular. But then what if we have like an emission? So like, you have to find, yeah, basically it's just a bit of nonsense. So what they decided to do is they decided to, rather than overhaul like framework shaders, to create a universal shader. The universal shader basically has a list of all the different textures, all the different things that you can stack onto your object. Some of you are probably going to have a heart attack looking at this. We're going to say, oh yeah, there's loads of empty slots. So for example, our cat, this little cat here, he for example has a specular map, normal map, and occlusion map. Basically what Unity will do is it will take that, it will compile it all down, and then basically that's one draw call still. So you can stack like 8 textures onto your cat, and that's one draw call. So yeah, yes. Okay, so let's get rid of all this stuff. Okay. So my cat is super boring. Okay, so this is my cat. Super boring, super lame, it's just a standard diffuse type thing. So what we can do is we can play around with different things. So the universal shader is kind of made for like 90% of like static objects you bring into Unity. So for example, flashing light. That's worrying. Yeah. So for example, this bottle, this phone, me, I'm not static, but yeah. Like the projector, like the table, the floor. If you look at them, they all have some element of shininess, some element of like specularness. So for example, this is going to be shinier than this, but this still has some shine in it when it's tilted in certain ways. The floor is very shiny. That light is, I guess, kind of shiny. This isn't that shiny at all. So yeah, basically everything has certain shininess. So the universal shader by default has a smoothness or shininess shader. So as I play around with this, so you notice with the shader at 0, the cat does not look sexy. Whereas if I raise up the shader, the cat looks sexy. Oh yeah. This also reflects the things in the nearby scene, but I'll talk about that later. That's the cool stuff. This is all boring stuff. So we have the specular slider there. We can also change the specular slider. So by default it's black. We can change it to like tint red. We can change it to white. So the cat is now like a mirror. of like the scene around it and stuff like that. Just by changing a slider. Well, it did. Okay. Is that easy on your eyes, or can John? Is that a bit easier?
Yeah.
Oh, sorry. I'm so sorry. I should have done that. Okay, so we've got sexy cat, right? Sexy cat is reflective. So what we have here is we have a specular option. So we can either use the built-in specularness around the whole object, or we can actually bring in a specular map. So our artist has created a texture, a normal map for the texture, an occlusion map, and a specular map as well. So let's go to cat. Let's apply this, not the doll, specular map onto the cat. So this is basically going to highlight the specularity of the cat, so the cat is now like a shiny object, a shiny ball. Okay, so what else do we have? Normal map. Okay, so let's do that. Normal map. Okay, so we've got our normal map cat here. So we notice that the cat now has a normal map until it has ridges. So rather than I say it needs to be more normal, or I mean it needs to be a bit more bumped, the normal map on the spectrum on the universal shader has a slider. Ah, right. So if it's at 0, that's like no bumpiness. Okay, so that's the cat after drinking all night. Whiskey and vodka. That's the cat the other way. So basically, we can actually change this normalness. So for example, rather than me going and pissing off the artist and saying, could you make it more bumpy, I can actually just kind of scale up the bumpiness and make it more. So this is more like a deflated balloon type stuff. I'm very sorry for it. Okay, so what else do we have? We have an occlusion map. So say like I find his ears a little too light, his mouth is a little too light, so we can actually like take an occlusion map and add it in. So the occlusion map there, which basically highlights, you know, like his mouth and makes his mouth darker and stuff like that. So let's go to cat. Let's add in an occlusion map. Oh. And he now has darker ears. He actually looks a bit better now. Actually, still looks really ill. Yeah. Okay. Cat is doing stuff like that. That's great, that's fine. So we've got a cat, we've got sliders. Yeah, like I was saying, some of you optimize for mobile, probably having a miniature heart attack, but there's lots of empty slots. Basically what it does is because it compresses it down, it's like a pay-as-you-go system. So what it will do is on build, it will basically take the texture, take the specular, take the normal map, take the occlusion data, pack that down and just say, oh, ignore the other slots, for example. So it kind of is a pay-as-you-go system. If I took all this stuff out, that will just treat it as a bump diffuse map, a bump diffuse material. If I have the spectrum like that, it's a bump diffuse spectrum. If I have down the occlusion, bump diffuse spectrum with occlusion. So obviously the more you add, the more like complex the material is, but it's still one drawable. So yeah. Okay, watch it else. Okay, let's turn him into a rock. So we've got the cat. I'm going to peel back some of his properties. So let's make him have like base nothing. So we have the cat here, and he has a texture to basically say he has like white eyes and he has like a mouth and stuff like that. What I want to do with the cat is I want him to say, this is your texture to say what you look like. Here's your texture to define how you feel. So whether you have like cracked rock, or you have like straw, or you like silk and stuff like that. So luckily, our developers, they've got main maps, secondary maps, and with the secondary maps, you can add a second normal map. So I can make him like a bumped balloon, and then make him a leather bumped balloon with a bump map for leather. Okay, this is where it gets confusing. So, okay, I'm going to, where's the secondary maps? I'm going to crowdsource this next bit. Which one do you guys want it to be? Cracked, which is like rock, leather, noise, a pattern, rock, silk, or stick? First one shouts out, please. A rock. Well, okay, so cracked and rock, they're like the same stuff. Either shout out really quickly, or like hurry up, a bit of awesomeness. No. So underneath this cracked folder here, this is just a simple texture and a simple normal map. So the texture's not been told to be like transparent. It is just a base texture, like everyone's Googled tileable floor tile at some point and stuff like that. And we have a normal map for it as well. So what you can do is you can select the cat. Let's go to a lighter area so we can actually see this in process. Go to the secondary map down here. Let's apply cracked style to it. So the cat now has a cracked tile all around it. But it's really flat, it looks really lame. So what we can do, it looks screen again, like that. Okay? So what we can do is we can then add a normal map onto him. So now it's kind of like cracked. Okay, let's change the time now. Let's change the time to like 5. Okay, let's make him a balloon as well, right? People are just like, what the hell is going on right now? So he's now like a bump map balloon cat type thing. And let's change the slider, so he's now like shiny bump map balloon cat. Like, okay, that looks crazy. Okay, let's go back. Okay, so that's cracked. Okay, so I personally like, okay, what? Which one do I like? Oh, I like leather. So let's place leather onto him. Now it's got like a new leather map. But what you can also do with this bump map stuff is you can actually say where it multiplies, it overlays, it adds or mixes. Currently it's multiplying with it. We can add it together. So we've basically got the texture map and the secondary map and the map. We can then mix them. We can overlay like one on top of the other. So we're overlaying the first map onto the second map. This one we're mixing the first map and the second map. Well, we're multiplying them together more like. So yes, we can do all sorts of sexy stuff like that. As well as just using sort of base like white and black and normal map, you can actually use other colours. So for example here I've got, no, wrong one. So for example here I've got this pretty pattern which is on like the dolls, like the cloth. I can apply this to the cat. So I can say to my cat, it's now royalty. So here's the highlights, and now I'm mixing the highlights with his like map there. Okay, I feel sorry for the cat, so let's go. So we've got here our doll. My girlfriend is jealous of her. What we have here is basically, we have the doll's cloth, is basically using a universal shape to basically tell it looks like cloth. The doll's face is a universal shape to tell it looks like face. The rock, the cobblestone on the base is using universal shader, as well as is the shininess of the wood. It's like quite a versatile shader. So for example, like the Viking village and everything in this. So for example, the Viking village, which is here somewhere. Oh, it's all like Viking village, everything there is universal shader, everything this demo is. So you'll notice that that has a different sort of scene and a different lighting on it. So luckily our developers, they've made something, which this is, okay, so what I showed you so far is kind of like the boring stuff, this is the cool stuff now. People are like, what the hell? Okay, so what you can do is you can sample the skybox, so in this case the cube map and the surrounding scene, and use the lighting from that and apply it to all your objects in the scene. So if you have a really complex scene, you can get the skybox, get it to generate the light in the scene. Our developers who make this demo in Stockholm, in Sweden, which is probably why there's lots of strange stuff in it. I guess that's Swedish like. It's weird stuff with meatballs. What they've done is they basically made like a demo so I can cycle through and basically will apply lighting to the environment. So for example, if we have here, if I go to my cat, it's basically using the lighting to make the cat shiny. And what it also does is it finds out where the light parts are in the cube map. So for example, light is coming from that direction up there, but it's kind of dark from like this direction. What you can notice is that the cat is here, dark, but his butt is light. So for example, it's light in that direction. Also look at like the cog on the back of the doll, as I swap between them. So yeah, basically it's using that lighting. So what I'm going to do now is I'm going to show you what it's actually doing there in a completely different project. No, not TED. Shield reflection. Whoa, okay, ignore that. So I've got a simple like Japanese scene here, and you can see we have the skybox in the background, for example. But what you can do is we can go to Edit, Scene Render Settings, and here we have a list of all the render settings about the scene, so like fog and stuff. we have here skybox material. But what I can do is I can set the light of the entire scene to be flat. So this is how Unity works. It's basically you tint like everything in the scene to be like the glow of red and stuff like this. And by default, it's like this weird, like bluey grey. It's all Unity game kind of like that. So you can tint it so everything in the scene is kind of like got a tint of yellow. It's like an ambient light. What developers decided to do is rather than just flat, so rather than just super boring and flat like that, you could then set it to be, instead of just flat, hemisphere. So you can actually define the top colour and the bottom colour. So someone pick a top colour. Pink. How did I guess? Someone pick a bottom colour. Okay, so what you'll notice that a lot of objects in the scene, like for example, like are orange underneath the rocks and pink at the top. And you can see in like the preview here as well. So for example, if I'm making a game like, I can set like red in the bottom and then like blue in the sky. So basically you've got the red symbol on the bottom of the objects and blue on the top of the objects. As well as setting that, they went one further and made 3. So you can have blue in the sky, yellow in the middle, and red at the bottom. Or you can set it to be the skybox. So it samples the colours of the skybox, which you can see here. It's kind of like murky, like mountains and stuff like that. And it samples that for the terrain the scene. So you can see the scene actually has kind of like a similar sort of colour scheme to the skybox when it's imported. So what happens if I actually change the skybox? It will change the colours of the scene. So let's say the skybox is now nighttime like that. So it's super dark. So if I go edit, see many settings. Okay, some of it changed. Okay. Okay, so I changed it to a field. So this is a big open field. And some of it's changed to green. Let's change it to a library. So I've got a library that looks like that. It's kind of like all dark orange. So what I can do is I can then say library. It will tint sort of like dark orange to some of the objects. The bridge isn't changing. It's an alpha, okay? So you know that. Cool. Let's go back to the daytime.
How fast is this on a mobile?
Very fast.
Very fast.
Yeah, because it's changing the light. It's generating a directional light based on the skybox.
So
it's
this
not like-
demo can run on a mobile device?
Yes. You got a question?
Can you tie the shader controls like intensity or cold also?
I couldn't hear you at all, sorry.
Can you tie the universal shader properties? Can you change them in cold?
Yes.
Yes.
You can also apply the universal shader to the UI. So the new UI system, you can apply the universal shader onto the UI and have it like a specular cat, shininess cat in your UI as a button. It's quite mental, like it really is. Okay, I've got 10 minutes left to talk about a lot of stuff. So what it does, it actually generates this directional skybox. That's what the Q app does. The basic directional skybox will be set up for the product. So that's cool and all. And what you'll notice is that if I go back to, if I look at my shield, it has a specular map on it. It has a specular map on it. And the shield is reflecting things in the scene. So anything with specularity on it wants to reflect things in the scene. So what you've got here is you have default reflection. So we're saying everything in the scene which has some shininess on it is going to reflect the skybox. So that's great for an outdoor scene. So for example, if I go back to my cat, which is here, it should open this quick. On the assets. Okay, so for example here, I've basically got like, as I swap through, as I change it through, basically this has a specularity, which basically reflects, you know, the skybox. Basically everything in the skybox is being reflected some specularity. So someone's about to point out a problem with this. What if it's indoors? What if you don't have a skybox in your game? Okay, that's fine, developers have thought of that. So this currently reflects all of the skybox. And if I go to my cat, which you can see here, and I basically make my cat look like crap. So my cat reflects the skybox, right? But it doesn't reflect the doll. Look, it's not reflecting the doll in the dark. It's not reflecting the doll, it's just the skybox. So what it started doing is edit scene render settings. It's basically saying reflect only stuff in this reflection texture, don't reflect things local to it. So a better example is the shield. So for example, in the shield demo, what I don't want the shield to do is I don't want every single object to reflect every single object around it, because that's really, really costly in processing. Basically anything with some shininess. So this bottle has to reflect everyone in this room, as well as this cup, as well as this bottle as well. And that's really optimized. So what the developers decided to do is they decided to basically make a reflection probe that you drop somewhere in the scene, and it samples the nearby reflections. Because if you think of a game where you have like a suit of armor, you walk through a cave, you don't care if it doesn't reflect some item that's like an hour further into the game, because you don't see that item. You want to reflect stuff near it. You want like dragon shoots flames and the flames come past your armor. You don't care if like a torch like 2 miles away doesn't reflect in your armor. So the reflection probe has been made to basically reflect nearby locations. So we have here like a little shield. As I move my mouse, you can think, oh wow, the shield is reflecting. However, it doesn't reflect the bridge, it reflects the skybox. So as I aim it up, it's reflecting the skybox. As I aim it down, it's reflecting like the skybox. It's not actually reflecting the main bridge. Now I don't want it to reflect every single item in the scene, only stuff within a certain range. So what you can do is you can add, so you can game object, create a reflection probe. The reflection probe will basically create a cube map based on this location. So if I place the cube map like here, okay, let's place it like here. If I zoom into the reflection probe, this is what basically this is what the reflection probe is going to see. So it's basically reflecting all of those items within that particular range, that whole range here. And then we can bake that probe, and it will actually give us a cube map that we can use. So if I go to light map, and we just go make probes. What you'll notice in my project folder is I've just made a cube map, a texture, over that location in the scene, which I can then apply to objects. So you can bake the probe basically to say, bake the probe, and it basically looks like this. This is what it's going to look like. But as well as baking the probe, you can then set it to real time. So if you think of a corridor that your character walks down, it's a very dark corridor, but nothing moves or changes in the corridor, the light stays the same. You can bake that corridor, bake the whole reflection of the corridor, and then apply that once. So it's not constantly updating, it's just you made a cube map. If you set it to real time, as you move it around in the scene as things change, that cube map will update. So it's useful for like having like, say you've got a cave, and you want the cave to like reflect on all the different things inside the cave, bake the cave, but you want a suit of armor, and the suit of armor guy will basically walk through and he'll have like a cube map basically reflecting dragon flames and stuff like that. That would be pretty cool. So for example here, if I get into the reflection probe, go away. The shield here currently is reflecting the bridge. However, what you'll notice is the shield has a reflection probe attached to it as an item. If I turn it on, and I go to the shield's render is basically saying use reflection probe. I can specify which reflection probe it's going to use. And now, look at my shield's reflection. I now have the bridge. Because this reflection probe is basically updating in real time. You can tell it when to update, so you can say update every 4 seconds if you're not that system. You can set the resolution of the update. So now what will happen is as I reflect the reflection probe, oh yeah, 60. So this is where it gets good. Okay. So we have our shield. Our shield has a universal shader with a specular map. If I take off the specular map and then change like the shininess to like here, for example, you can actually see it like indeed. So what you can do also is you can stay at scale with like the reflection probe down, so it's basically going to be really crap quality. So it actually updates a lot faster. So cool. And you can also drop it up to like 1024, so basically it's going to look super nice. But it takes lots of lots of power to do it, yeah. So I mean, probably you want to like drop it down. What I find in tests is 64 is actually fine. So even though it's not completely perfect, if your character's walking along like a suit of armor and a dragon shoots flames You just want to see that there's red flames in your shield. You don't want to see the exact cut outlines of the flames. You just want to see that a red glow comes past it. I took the teddy bear and I put the reflection probe on the teddy bear and turned the teddy bear into a mirror, so you're doing hardcore reflecting all the things around it. So yeah, I like the teddy bear. Cool. Right, so you have the reflection probe. There's a lot more to it. I have 3 minutes, so I'm going to talk about 3 features quickly. The next one is this stats panel. So if you look at the stats panel, this is a really optimized scene. It's 1,122 draw pools, which is a lot of draw pools. So can anyone tell me exactly which is a draw pool in the scene from face value? Like what's static, what's dynamic? You can't really. It's kind of like a guessing game, so you kind of have to say, oh, okay, so like, let's get the shield, turn off the shield. Okay, that was like a couple of draw pools, I guess. Okay, let's get the bridge. Let's turn off the bridge. That was only 17, so like, it's kind of like a guessing game. And the profile is useful to an extent to basically show you like what you're profiling, but it's not that visual. So here is where your minds will be blown. So we have a frame debugger. Frame debugger shows you exactly which draw pool is on which exact frame. Here we go. So my UI. Let me just close all this stuff so you can actually see what's going on. Okay, so I've got my UI. Basically, the camera is rendering nothing. And then as you go through, it's going to build up all the drawing of the base meshes, as well as some post-processing effects. You can scroll through, you can see what's actually being drawn in each frame. So the post-processing effects are going to blur it and blend it and stuff like that. You also got light maps and stuff and different things. This is where it actually draws up all the meshes. So you can go, these are all the separate variables, this is really optimal. So obviously, it's getting there. This is the terrain tool, which is basically crap.
Is this a pro feature?
I think it's really. We haven't made like a list yet of what's free and what's pro, but it's a big fight to get as much stuff as we can into free. Marketing don't like it when everything's free. No, finance don't like it when everything's free. Because they're like, we do need to pay our people at some point. Someone actually posted in the forum saying, because people at Unity enjoy their jobs, they shouldn't get paid. Some guy responded, it's like, yes, that's why we haven't shipped to GUI, because our CTO has been working 4 shifts at McDonald's every evening to pay us. That's the reason why GUI's not shipped. So what you can see here is like, oh, the shield is being drawn. Oh, the bridge has been drawn. Oh, but I'm now adding all that crap around the outside edge. This is a really optimized scene. So it's actually a really good example. You've got every single cobblestone on the bridge is a separate mesh. What the hell? Who made this? It's nice. So obviously you can see here, like for example, you could then like batch them all together. So like take all those objects into Maya and then make them one mesh, and then clip all the trees. So I can see like this here, and look at this, a bit of bridge. Look how exciting that is. You can also see how many verts and indices this is. You can also see like what shader it's using, so bump specular. You can also set the RGB value and see that, and play around with like all sorts of like channels and weird sexy shit and stuff. Well, basically, you can just scroll through it again. Basically, cycle through it. It also shows post-processing effects. Basically, anything your camera can see will show you what's in the draw pool. If you say like you had like a bunch of physics objects all dynamically batched, it will show you all those on that particular frame, for example, like 50 objects on that particular frame. It will show you static. It will tell you it's a, rather than draw mesh, it's like drawn static mesh, and then it will show you like, you'll select like, for example, here, and then you'll go like, yeah, this bridge is terrible. Okay, so it will show here, and it will show you like 10 rocks if they've all been batched and stuff. So everything is static, so very good. So yeah, so the draw pool debugger. Oh, you also have a copy button. You can run it mid-scene as well. So say like you're walking along and then like a goblin jumps in, and then the frame rate takes a hit, you can pause it. So this is currently running without in play mode. So I can run it in play mode, pause it, enable it in play mode on that particular frame. So if a goblin jumps in and then it gets frame rate like peaks and stuff, you can pause it and you can see how many draw balls are on that goblin. See that there's like 500 and then go sack your artist. So yeah. Right, I have -1 minute to talk about two massive features. So Unity 5 is too big for like an hour talk. I need to do separate. Okay, so the next one is, so that's just all the rendering stuff. That's just one little sub bit. So the next one is, I hate marketing speak, I hate business speak, and all, I hate all like buzzwords and stuff, it's stupid. So cross-platform real-time global illumination is a load of nonsense. But that's really what it is. Our new lighting system is cross-platform, it's real-time, it's global, and it's illumination. So so basically what we did is we approached Geometrics, who make Enlighten, or they license it to proprietary engines. So engines that use like Battlefield, Mirror's Edge, Need for Speed. We basically bought it and then put it in Pro, which is cool. So basically you'll be able to have like that running on your own device and stuff. And basically the way Enlighten works is it will do real-time global illumination, but also it will do mini light map bakes. So put your hand up, if you use the light mapping system, you set up your shadows, you click bake, it takes like an hour, and then it looks like crap. Okay, right? And then you clear it, you go back, you tweak it, you rebake it, and then you're like, I just do this in mine, right? Okay. You're like, oh yeah. So the way that lighting works, and we've got like a working demo where it won't like go crazy. The way that lighting works is as you move an object, so say like I move this bottle, it will then bake that bottle. It will just calculate a rebake for that particular little item. So as you build up your game and place your scenes, it does little mini tiny bakes in the corner. You can turn this on and off to do tiny bakes if you'd like to click bake and then go make dinner and then come back and check what it looks like, or go watch Mad Men, which is what I do. So every time I place that bottle, it would then allow me to like bake just that like little bit there. So it does tiny little bits rather than baking. If you move a barrel, it bakes the entire scene, which is crazy. So it does mini bakes in the background. So the idea is you'll be able to build up like a scene like this, and all of your shadows will look like what it's like in the end bake. And then you finish your game, you're like, oh, the light map is already done. Cool. It also works on like moving objects and stuff. So if you have like cars, they all work in there. So you have baked and direct lighting, iterative baking, scene will represent and bake. So as you set the shadows up, it'll look like that. You have a question?
Do you still need light map UVs?
Light map cookies.
UVs.
Light map UVs.
Secondary.
Yes, no, I don't know. They're still implementing Enlighten. They're still kind of playing around with it, but you will have like access to like the light maps that can do stuff with them. So I know some people are like, I'm not quite sure either. Send me an email, and then I'll ask them if you guys. Cool. That's the easiest way to do it. Unfortunately, only one person knows every single little thing about Unity is our CTO, and yeah, he never stops working. People are just using it. Okay, so we've got WebGL. So this is the last thing, I'm -5 minutes. So basically, about a year ago, we started working on WebGL building in Unity, because the plugin in Unity, some people don't like. Some people don't like the fact you build a game and you send it off to like a little kid and it has to download the plugin and stuff. So we started looking at WebGL. And a year ago, WebGL was kind of being used for like, oh, here's a 3D model of a web page, you can rotate it. Oh, here's another 3D model, you can rotate it. And it's just super boring and lame. And we said if we wanted to release WebGL, we wanted people to release 4 games in WebGL, like actual playable games that run kick-ass like that, for example. And I'm going to show you something like that, similar thing like that in a second. So we approached all the browser providers, so like Google, Mozilla, make Firefox, and Microsoft. Apple don't like playing ball or anything, so they approached us later on. So basically, we were working with the other 3, and we are basically working with them. And the first time the WebGL system worked, it output you're going to laugh, a 1.2 gig JavaScript file. This was like over a year ago, right? And they were like, but it worked. They had a cube spinning in WebGL, but it's 1.2 gig of JavaScript, which is mental, right? So what they did is we worked very closely with Mozilla. We had them come on site with us for a week. We went onto their site. We basically worked closely with the browser providers to make sure that our WebGL experience was as good as possible. So we had so many emails saying like, I just trimmed another 100 meg, hooray! I just trimmed another 4 meg and stuff. We've got it down to something like, I think the goal in the end is like 4 meg. Compressed, and it's currently about 15, 16 meg, I think, or 17 meg or something like that. And it works best with Firefox because Mozilla work closely with us. Safari kind of were like, okay, maybe we'll do WebGL, we're not really sure. Then we released this demo, and then Apple were like interested. So so I'm going to run it in Firefox nightly, which is like the Firefox development build. It does work in like Chrome and Internet Explorer, weirdly enough. Nothing works in Internet Explorer, so that's quite impressive. Wow. It works in Internet Explorer before Safari. That's even more impressive. Holy crap. Yeah. When Microsoft are actually ahead of the game. Shit. So I'm going to open up AngryBots, which everyone loves. Okay, so this is it running in WebGL. It looks just like, kill that, kill that, kill. Okay, let's go in here. What's in here? Some reflective stuff, kill that. This is like a 4-year-old demo, so that's pretty nice. So yeah, this is all running without a plugin. I could send this to my NAN and get it to run around and like robots if I wanted to. It basically just uses all the existing stuff, it just exports it, and it's all fine. Some of you are probably thinking this is bullshit, he's like kind of like tricking it. Well actually, okay, so let's go to the source code. Okay, so I'm going to be like, whatever code. So what you notice here is we have CSS. We draw out onto the canvas using the scripting. So we've got like support for Mozilla, support for WebKit, support for Microsoft, support for like, other stuff. We've got the module and all this stuff. And what we now have down here is we have the file loader, which is the loading bar, and we have output.js, which is our game. So if I open that up, this is the game, right? But it's all like locked. I can't go into here and think, I can't play some sort of GL game and think, oh yeah, I really like that, like the bin there, I'm going to steal the bin. You can't do that, for example, it's all locked down. I can't then go and steal people's stuff. So it's not like other WebGL where you can just steal people's stuff. It's all like using scripting to say, haha. But that means no one can go and steal this like agent and stuff like that, which is a shame. So yeah, another cool thing is that you can do JavaScript calls from buttons on your web page. So this is a separate button to the game, and then have the game send JavaScript calls to the web page. So rather than just being a holder and being like, deal with it, here's a little JavaScript button that basically just makes your game full screen. So this is running without plugin. 4-year-old demo, which is super unoptimized. Kill that. And audio actually works, which is amazing for HTML5. Because it does not work. Yeah. Cool. There's a couple of things they won't support on release. Microphone, for example, it doesn't like microphones. I don't know. It doesn't like. Oh shit. So I think my NAN would have died by now. Yeah. Yeah, so it doesn't support microphone. I think webcam, they're trying to get done, but it's a bit weird. There's a couple of other things. So this is our own demo. People see this and they're like, all right, that's your own demo. You can just basically like, hack it. So we approached a company called Madfinger. Madfinger were the first company that sort of used Unity that had over 3 employees. We've been friends with them for so many years. So whenever we get any new tools, we kind of like give them tools to play with because they're like our first friends. So they heard about this from our CTO, and they were like, we want to like take one of our iOS games and build it to WebGL for GDC. So they did. So here is Dead Trigger, which is on all of our trailers and stuff because they asked it to be. So left or right? Left one's, no, right one's better. Right. I was going to click that one anyway. So that was actually a button in Unity that then goes to like the web page and then render it full screen. So we've got basically an iOS game. It has lens flares and shit like that. We've got zombies. You can actually see it. It even has like the iOS buttons just left on the screen, so like, which is amazing. Shit. Okay, so some people think like Unity is a very serious company. So in our demo, we have a chicken with a machine gun. Okay, here's a second chicken with a machine gun. Oh, I'm dying. Yeah, so basically, yeah, this was in like these chickens are badass. I mean, I didn't need to do anything. Well, come on, chickens. Don't get so close. What are you doing? Chickens, come on. I'm really worried. Okay, cool. So So yeah, this is like a whole iOS game. So yeah, 2 to spawn a chicken. They showed this at GDC and people were like, you guys are weird. You're Danish. Sure. Use a chicken. This is next gen video games right here in the browser. Imagine if I said this to my nan. Christ. Got a heart attack. So also escape will basically do the JavaScript tools to make it go there. But I can't like go into here, and if I think that chicken is badass, I can't go in and then find like chicken in the JavaScript file and steal the model and the animation and stuff like that. So yeah, I can't go in there and then steal like all the animation and stuff. This is all encrypted. This will be a build option. So like in, for example here, so for example, with the web player, there's pros and cons to this. So that was pretty cool. But like with the web player, we had full control over what was in the web player plugin. We could basically optimize it, do whatever we wanted with it. However, Google don't like the fact that people have control over plugins on their browser. Cheers, Google. So what we're going to do is Unity 5 comes out. That's when web player will still be supported for those people who still want to make web player games. WebGL will be supported. But like WebGL is not quite at the same level as a plugin. WebGL is still kind of growing. People aren't really sure how WebGL works and stuff like that. People aren't sure like what the direction is, how they monetize from it. Like, is it just for 3D models and just saying, oh, it's in the browser, or is it actually for amazing content? There are a lot of companies who like are big and stuff, and I can't say their names and stuff, who are like investing heavily in WebGL because they like see it as the next feature. Oh, again, Lego, for example, they made some WebGL demos. Has anyone seen the one where you build like a square of Australia, and then you have the whole of Australia built out of Lego? It's all in WebGL, which is pretty cool and stuff. It's like Lego interested in it and stuff. So it's kind of like, so over the course of Unity 5, we support the web player and WebGL like parallel. And then I think in like a couple of years' time, we're going to see like if WebGL has overtaken the web player and then kind of see where browsers are. I mean, in the last year, WebGL was like shot up, so hopefully it will shoot up further until we kick ass. So yeah, I can take, yeah, so take this build to WebGL if I wanted. But currently the build process takes a little while, and they're trying to trim it down quite a bit, so yeah. But it's getting there, so yeah. I have minus 14 minutes. Oh my god. So yeah, that's basically it. So Unity 4 looked like this, right? The entirety of Unity 4 was this, right? Oh, animation stuff, some Windows stuff, some 2D tools. Right, Unity 5 alone. So that was probably like 1/5 of Unity 5 I was talking about. The whole audio mixing system. You can actually add scripts onto animator, like transitions and stuff. UGO system. There's a whole cloud system as well for cross-platform ads and things like that. So basically, the release version of Unity 5 is twice as big as the release version of Unity 4. All of our developers have pointed out, code-wise and feature-wise. And we were like, how the hell did this happen? And it's like, oh, we hired people, I guess. So the future, so we're already planning on like after 5, what's in 5.1, what's in 5.2, what's in 5.3, basically the future, rather than just like releasing something and then kind of like being like, oh, what do we do now? Yeah, so 5.1, we're overhauling basically all of our old stuff that has really aged. So like UNet is our full native networking, so basically, there isn't that much information on it though. So full native networking, rather than the previous networking was done by someone who's never done networking before, like years ago, we've hired guys who've worked on like World of Warcraft, League of Legends, guys who've actually worked on like Battlestar Galactica Online to actually come and make it. So we've hired people who have made World of Warcraft, right? Some of them, not all of them. We haven't bought Blizzard, Christ. Jesus. That's ridiculous. We also want a new input system, more 2D features. There's lots of other things, but the best place to go is the Unity forums. So the Unity forums previously was like most of our community would focus on it. And kind of like recently we were like, okay, we need to give our developers a big kick up the backside and actually talk to our community more. So what have they done? It's like the guys who handle the input system, the guys who handle the 2D system, the guys who handle particles are like, what do you guys want in particles? And then people are just posting like massive amounts of content and they're like, okay, we'll do all that something. So you can go and like argue with our developers and ask what you want basically. There's lots of other things in 5.1 in the future. Some stuff that's like going to be really cool, some stuff that's going to be announced very soon. Some stuff we want to do, but we need to get around to doing it. Lots of things are requested. I can say the most requested things that we are aware of is like a node-based shader editor, which everyone asked for. Visual scripting, which everyone asked for. Some video stuff. So these are the most requested things that we have on our hit list, basically, to do. We just need to get around to doing it. But we thought we'd have a load of other stuff instead first. And that's basically it. And this is my favorite Twitter account of all time, just quickly, is Twitter Dan GUI system. So every time we post a blog post, this guy has made a bot that every time we post some news, it posts, can Unity just fix the damn GUI system instead of shiny new animation features? Can Unity just fix the damn GUI system instead of serialization in Unity? So every time we post some news, it just says, can you just fix GUI instead of doing all this other stuff instead? So it is amazing. We're big fans of this sort of stuff. Also, this is a is the new GUI out. But Tim C, who's our lead on the GUI, who's like lead visual like guy on Bioshock and XCOM and stuff like that. He's like, but we are close. So yeah, 4.6 it should be. So I'm looking forward to the day where that goes, yes. Which will be pretty awesome. So yeah, I'll be very happy when it comes out and stuff like that. And that's basically it. I'm aware I've overshot, so I apologize. We have a game jam, a hackathon type thing. If you need like a Unity license, so like a free pro trial with all the bells and whistles and everything with pro, you can have it until like 20 January. So you can have it for the hackathon. You can have it for the hackathon, and then after the hackathon, then like actually push it again and release it and stuff. So there's that code. There's about 100 activations. If there's more hundreds of people, then like go and do it. I'm going to bundle all the assets together from the spaceship game, like the finished version, and if I send it to Kalina, can you send it by email or something? That, rather than me taking down every single one of your email addresses and stuff. And that's basically it. I've overshot, so I apologize. I'm getting told off. No, it's okay. So yeah, thanks. Thanks for like letting me talk to you guys for like 10 hours. Thanks for being in like a super hot room. Thanks for having me in Bulgaria. It's amazing. I've never been to Bulgaria before, and I want to come back already because London is miserable and rainy and cold, and this is shorts weather. You guys have been really awesome. Rather than most crowds are like, they also ask colours. Like we have to think of a name. You guys have been like, boom, yes, this. So you guys have been totally awesome. So yeah, thank you. Thanks for making myself and Joanna feel welcome. And I are going to take part in the hackathon as well. We're going to try and win a Unity license. So I'll be very happy. I'll be very happy if I win a Unity license and stuff, despite the fact I have 5 on the screen.
I can make you a discount then.
I can have a discount. Oh, sweet. Yeah.
I can make a slide.
Yeah. So basically, yeah, we'll take part in hackathon. I think we're going to make some like paint watching game, paint simulator, or rock simulator, or dog sim. I don't know. I don't know, we're going to make something, so it's going to be cool to see what you guys make. But my advice is get some sleep at some point, because anyone who stays up all night, their hackathon projects always turn out to garbage. Get sleep. Sleep is good. So yeah, and eat lots of food. Yeah. And that's basically it. I'm going to stop jib jabbering now. Basically, just play some laptop. And unplug it.